Alright, it seems that we are live now. Just 1 second, we will start our session. Mm, yes, here we are. I'll just check. Okay, good. Let's begin with our today's session. As I said, today we are going to talk about the white box testing. Okay, so let me remind you, since last few Saturdays we have started the live sessions. Every Saturday we come live and we talk about the manual testing, software testing. It is for beneficial for the people who have just want to switch their career into IT industry, but at initial level we are actually scared of the programming, but somehow we want to go into the software industry. So manual testing is just beginning, right? So you should learn the further things as well. You will not escape from programming. You have to learn the advanced things as well, right? So since since last 5 sessions, we have discussed different concepts from manual testings, right? And we know that software testing is essential, because without testing your product should not go out. Once your product goes out, then if it finds certain issues in it, the client won't be happy, and it will be a big uh, disadvantage, you can say, or it could be loss of your company. Fine. So software testing is must. Software testing is nothing but evaluating or exercising the software application. It can be a desktop application, it can be your web application. So evaluating or exercising the software product in order to find bugs is software testing. Fine. So these sessions are we are conducting every Saturday, and uh, here, if you have not subscribed to this channel, so do subscribe to youtube.com/amol ujagare, right? And in these sessions I'm sharing notes also with you. I'm writing something on the notepad, also I'm showing some PPTs. So those PPTs and those notes, if you want, then you can join me on Telegram. So amoluzagare.com/telegram. Just open this link and you will be connected to the Telegram group, right, wherein you will get all the notes like this. Even in the last session notes also I have shared. You see here, up to fifth sessions uh, we are completed. We have completed 5 sessions. Last session was black box testing, right? So it's PPT and the notes also I have shared. So let's begin with today's session. So today we are going to talk about the white box testing. So just 1 second, I'll open the presentation for white box testing. White box testing. Okay. So what is a white box testing? So let me tell you practically. If suppose you have a project, so let me open one project which I have already installed on my machine. It is a web-based application. So just look at this. This is a billing software. Local host /IP So this is a billing software. When I do log into it, I can see a dashboard. Okay, so there are various functionalities we have here. So mainly two types we have seen in this, types in the sense techniques, right? Two techniques are there for doing testing. One is black box testing, another one is white box testing. So in black box testing, what we do, we are least bother about what is written in the backend. What is the code implemented, we don't worry about it. We just check the functionality of it. Okay, we just do the functional testing. We just put the input and check whether the expected result matches with the actual or not, right? And in the last session itself, we have seen a lot of different techniques of doing black box testing, like boundary value analysis, equivalence partitioning, and few more. Today we are going to talk about, as I said, white box testing. So white box testing is something wherein you see the software internally, right? So if this is a white box testing and if this is your application, then you not just check the functionality of it, but you go internally and check the codings of it. Generally, this white box testing is done at unit testing level. Okay, we have learned the different levels of testing. So this white box testing is carried out at unit testing level, right? Mostly it is been done by developers, but it is good if the tester has a knowledge of a coding, and uh, the tester, if it checks the coding also. Fine. For example, in my organization, I used to do sometimes white box testing. Uh, the time when I used to do the testing, I don't have at that time I didn't have a lot of knowledge of the programming, but at least I could see some logic, and if something goes wrong, then I could have suggested. I used to suggest the different things to the developers, like so this error is there in this particular form, so this could be the issue. Let's say this. I'll give you a very basic example, simple example. For example, here it is email address, and email address, if it is not getting accepted, so or let's say email address is not getting saved, so maybe the variables that is actually holding a value or capturing the value and passing it to the database, might be there could be some issue. So these at least these preliminary checks you can do, right, at initial level. If you know the programming in detail, then definitely you can do the debugging of the code, and you can check where the things are going wrong. That's good. But even if you don't know the programming in detail, and if you just know the things at very surface level, still you can check so many things. Like, as I said, if certain field is not getting inserted, you can visualize that the code to insert this particular field might not be written. Fine. So I'll just show you its code. The code for this is stored at this particular folder when you install it. So let me just check. It could be here inside the XAMPP, htdocs, then IP, applications, and modules. Okay, different modules are there. For example, this client module. So you can see client controller, clients. So this is the PHP code you see here. So different functions are written over there, right? So if you know the coding of it, you can just go inside it and check by debugging it. Okay, you can put some debug point and check the debugging of it, check the functionality of it, and this is actually called as white box testing. Most probably white box testing is been done by developer only, right? And it is done at unit testing level. Now don't worry if you don't have the programming background, if you are not doing white box testing, that is absolutely fine, but you should know actually what is happening in white box testing. So in white box testing we have different types like statement coverage, branch coverage, and cyclomatic complexity. Means this black box testing we can carry it out with the help of statement coverage, branch coverage, and cyclomatic complexity. So one by one we will see what is a statement coverage. The statement coverage is known as a line coverage or a segment coverage which involves the execution of the all statement at least once in the source code. To find the statement coverage, we find the minimum path that covers all the nodes. Fine. So there are actually some questions been asked in ISTQB exam. If you attempt to give ISTQB exam, or even in some company, if you go for some interviews, and let's say if they give you a written test, then sometimes you will find some questions related to statement coverage, branch coverage, and cyclomatic complexity. So what we are going to do today, I will pick up some questions from the ISTQB past exams, and we will solve some examples related to statement coverage, branch coverage, and cyclomatic complexity. So first let me explain how are we going to do that. So this is the statement coverage. You'll be given a pseudo code or some sample algorithm like a code, and based on that you have to find, let's say, statement coverage or branch coverage there. Okay, so this is very basic example, but we will see some advanced examples as well. So here you see this is a pseudo code. Okay, so it is not getting typed here, so let's observe it here only. So this is a pseudo code. So look at this. It says read A, read B. If A is greater than B, then print A is greater, or end. Okay, so its flowchart can be drawn in this way. So you first start, then read A, then read B, and here if A is greater than B, then print A is greater than B. A is greater than B, and if it is false, then you don't have to do anything. So just stop. Now here you see, in order to find the statement coverage, you have to find the minimum path that covers all the nodes. Okay, so this flowchart is been drawn, and now you see there is only one path that using which we can complete or cover all the nodes over here. We can visit all the nodes. So its statement coverage is 1. Okay, and what branch coverage is? Branch coverage is something wherein we find all the true false branches. Okay, so in statement coverage we visit all the nodes, in branch coverage we visit all the branches. So here if you see the branch, we can see there are two branches. One is true when A is greater than B. There is a true section also, and there is a false section also. In false sections, although we don't print anything or we don't do any activity, but there is a section which actually takes us to the last or end of the statement. Fine. So here 1 and 2, like this, two paths are there. So here branch coverage is 2. Getting this? So this was very simple example. Based on this we will solve some more examples. So let's just open one document wherein I have some examples related to the ISTQB exam. Okay, so let's just see. See, this is very uh, interesting example. Look at this, quite a long one. So given that following code is there, okay, so we will just understand this, analyze this code, and we will try to draw a flowchart for it, and based on that flowchart we will find the statement coverage and branch coverage. Although it is been asked that how many tests required for 100% decision coverage. Decision coverage means branch coverage. So we are actually supposed to find the branch coverage, but still we will find both branch coverage as well as statement coverage. So this is the code. So it says that if your width is greater than length, then biggest dimension is equal to width. If your height is greater than width, then your biggest dimension will be height, and end if. Okay, so here this if it ends means this is one section of this if, and there is another section, so else. So in else, biggest dimension is equal to length if else biggest dimension is equal to length, and again we have if inside it. If height is greater than length, then biggest dimension is equal to height, and end if, and again end if. Okay, so let's try to understand this if started and it ended also. Again, this else started and this else started and okay, so look at this if, this end if belong to this if is not yet ended. Okay, so let me just see, this is else. Fine. So what we will do is we will try to give some brackets to it. So this is the first if. Okay, so this is the first if, it has started. Okay, and inside this, okay, this is the first statement. Inside this is the another block of if. Look at this. And this ends here. Okay, this is started, this ends here, but this if is not ended here, so it has a else part. Okay, so it has a else part, and in the else, this else is started. In the else, this is the biggest dimension, which is equal to length, and in that again there is one if. Okay, just like the earlier one, so if, and then this else ends, and ends if means here this end if belongs to the upper if. Okay, so this is how we have simplified this code. So if width is greater than length, then biggest dimension is equal to width. So let's try to draw this. Okay, if width is less than greater than length, so at this level width is greater than length. Width, I'll say W, and is greater than length. If this is the case, then what we have to do, if this is true, then first thing is that biggest dimension is equal to width. Okay, so biggest dimension is equal to width. Fine. Then the next statement is again one more if. So if height is greater than width, here again we are checking if the height is greater than width. Okay, I'll say like this, if height is greater than width, then biggest dimension is height, and end if. biggest dimension is equal to height. Biggest dimension is equal to height. Okay, fine. And here this ends. So here we have else part. Okay, so else what? Biggest dimension is equal to length. Else biggest dimension is equal to length. And after that we do checking if length is if height is greater than length. Okay, so if height is greater than length, and if this is true, then height is the biggest dimension. Okay, so it is something like this. Height is equal to biggest dimension, otherwise it is end, right? So again it has another branch, it has another branch, and it goes to the end. Like this. We'll draw one more node over here, and this is end. Okay, so it will come to the end. Fine, so this is how this diagram will be. Okay, so look at this once again. If width is greater than length, then biggest dimension is equal to width, right? And then again you have one if block. If height is greater than width, then biggest dimension is equal to height, and end if, right? Else part of it, if else part of it, it has biggest dimension is equal to length, and if height is greater than length, then biggest dimension is equal to height, and then end. So this is how this diagram it will look like. Fine. Now we have to find out the number of path which can visit, the minimum number of path which can visit all the node. Okay, that will be my statement coverage. So just look at this. I can see if I start traversing from here, so it will allow me to capture this path, this one, this node is also visited, this node is also visited, this node is also visited, this node is also visited. So this is one path. So from one path I can visit these many nodes, but these nodes are untouched. So what I'll do is I will just traverse from this path and this path and this path, this path, and in this way the another nodes are also visited. So here my statement coverage is 2 because there are 2 paths. Okay, so statement coverage is equal to 2. Fine. So there are 2 minimum paths which are required to traverse or visit all the nodes. So my statement coverage is 2. And what about the branch coverage, or you can say decision coverage? So to find decision coverage we have to see all the true and false paths or true and false ways. So let's see, this is one, this visits one true node, or let's say this visits one true branch, and this also visits one of the true branch going from the false branch of the first node. And let's just see if I want to visit this branch also, so I have to go through this path, so I'll go through this path, and this way it is. Okay, so this is the third path I have. Again, for this I will have to go from this path to this path to this path and to this path. Okay, so this will be the fourth path. So branch coverage, I can see minimum 4 paths are there through which you can visit all the true and false branches or decision branches. So branch coverage is 4. Okay, let's just see what they have asked. So how many tests are required for 100% decision coverage? Decision coverage means branch coverage. So answer would be 4. Okay, 4 decision coverage are there, 4 branches are there. So let's just see whether it is correct or not. So question number 16. Question number 16 and answer is B. You see here, answer for question number 16 is B, and what we have chosen? We have chosen B, 4. How? Look at this. This is the flowchart we have created for this particular pseudo code or this particular sample statement or algorithm, and once we do that, we found total number of nodes, total number of paths that can visit all the nodes, and that will be the statement coverage, but it is not asked here. And total number of paths, minimum paths that can visit all the true false edges. Okay, and it is the branch coverage, which is 4. Branch coverage is also known as the decision coverage. Okay, and the same it was asked here. Okay, decision coverage is nothing but branch coverage. Fine. So this was one of the example. Let's do few more. Okay, so once you understand how to write the flowchart of it, it will be very easy for us to find out the statement coverage and branch coverage. This is the next example. Okay, so you have to design you have designed the test cases to provide 100% statement and 100% decision coverage, right? So this is the fragment of the code. The following has been added to the bottom of the code fragment to the above. How many more test cases are required here? Means here you have to find the branch coverage and statement coverage when you have this much code, and again when you will add this code, how many branch coverage and how many statement coverage, how much branch coverage and how much statement coverage will be increased, that we have to find out. Okay, again it is very easy. The basic thing is that we are supposed to find this. Okay, so let's take this example here, and I will also copy the rest part of it. Okay, so first of all, let's try to draw the flowchart for this. Okay, just one second. What I'll do is I will put this diagram at one place so that you know whatever diagrams I have drawn, I'm putting it here so that you can have it in the notes section when you will join the Telegram. Okay, also this. Fine. So let me continue my notes here only. Let's better put it here. And this here. Okay, I'm going to share these notes with you. Fine. So what is the next problem? So if width is no, not this. Alright, if width is greater than length, biggest dimension is width. Is it the same? Let me just check. Looks like the previous one. Fine. So it is a shortest code we have if width is greater than length. So let's draw a flowchart for it. So if width is greater than length, so look at this. So here width is greater than length, so W is greater than length. If width is greater than length, then biggest dimension is equal to width. Okay, so biggest dimension is equal to width. Okay, else biggest dimension will be length. Okay, so this is the one. Biggest dimension is equal to length. Fine. So this is how the flowchart is for this much code only. So here, how many statement coverage? So you see here, this is one path which visits this node and this node, but this node is unvisited, so I will have to go through one more path. So this will be the second path. So my statement coverage is what? Statement coverage is 2, right? And how many branch coverage will be there? So branch coverage is, you have to visit all the true false nodes or true false branches. So look at this. So this is the one, let's say this is the true branch, and this is the another branch. So here also only 2 minimum paths are required to cover the decision coverage. So decision coverage or branch coverage is 2. Decision or branch coverage is equal to 2. Okay, so this is the thing, but this not been asked. We have been asked that if following has been added to the bottom of the code fragment above, then how many more test cases are required? Okay, so print biggest dimension is biggest dimension is, and biggest dimension print width and width. Okay, biggest dimension is length and its length. Okay, so in this pseudocode, what I understand from this is, so they are asking us to print what is the biggest dimension, they are asking us to print what is the width, and they are asking us to print what is the length. Okay, so 3 statements are going to be added to this pseudocode. So look at this. So after we do the comparison of it, there will be 3 more nodes added to this. Okay, so first node will be asking us to print, let's say this is actually the value of biggest dimension, value of biggest dimension. Okay, and then next 2 will be, we have to print value of width, value of width, and then we have to print value of length. Okay, so this will be the further steps. Getting this? Now as these steps are added, how many more statement coverage and how many more decision coverage? So look at this. If I want to traverse this node, so I can continue this path itself. Okay, and that's it. Another path is already there just to visit this, so statement coverage will not change. So 2 will be the statement coverage even after we add these statements. So is there any change in decision coverage? So I guess no. Here also there is one true path and another false path. So this will, the same path will traverse this. So decision coverage will also remain the same. So there are no more statement coverage, no more branch coverage. So here the answer will be none. Existing test cases can be used. Okay, so the answer is C. Question number 70, answer is C. So let's see. You see here, answer is C. 17, answer is C, right? So for this, I'll put this diagram. This is the diagram, and the answer is C. So have I added the options? Just a second. These are the options, and the correct answer is correct answers. Okay, so it is already added. So I will just highlight the correct answer. Okay, previous one also we will highlight the answer for it. It is I guess 4. Fine. So this is how you can find the statement coverage and decision coverage. Let's see a few more examples. One more example we'll see, and then there is a cyclomatic complexity. So as a manual tester you should learn this, and these kinds of questions will be asked, might be in the ISTQB exam or might be in your interview written tests. Okay, let's just see anymore. These are actually 500 question from sample questions from the ISTQB exam, which I have already shared it on the Telegram. If you are not a part of Telegram group, just join this. It is I have put this into the description of this video, the link to join the Telegram. Okay, so this 39, it quite looks like that. So the diagram represents the following paths through the code, like this. I'll just reduce the zoom. VWY, then different paths they have given. What is the minimum combination of paths required to provide full statement coverage? Okay, to cover full statement coverage means you have to visit all the nodes. So to visit all the nodes, you see here, from here I can go, then from here to here to here. So in just one visit I can, or in just one path I can visit all the nodes. Okay, so in order to cover all the paths, so I have to go through V, then W, then Y. VWY. So I guess this has been defined by this option A. Okay, this is the path VWY. If I go via this path VW and Y, it will cover all the nodes, right? So the answer to this question, that is what is the minimum combination of the path required for full statement coverage, means in order to cover all the statement, how many minimum paths are required? So only one path is enough, and that path is VWY. Okay, so VWY is the option from the A, so the answer is A. Okay, let me just put this into our notes. Just 1 second, it is mixed up, I think. Okay, so the answer is A. Okay, let's check this is correct or not. Question number 39. 39 answer is A. Getting this? So these kinds of questions will be asked. Let's see any more question is there. So quite like for calculating or finding the flow chart, if we find, we will take one more, and then we will see the cyclomatic complexity, how it is been calculated. So let's just see. So one of the example I have cyclomatic complexity. Okay, just scroll this or I will search it directly. So coverage. So this is one of the question. I'll just address it. Which of the following technique is not a white box testing? Statement testing and coverage, decision testing and coverage, condition coverage. These three are all the boundary white box testing technique. Boundary value analysis is not the white box testing. Okay, so I'll take this question also for your reference. Okay, which of the following is not the white box testing? Boundary value analysis is not the white box testing. Okay, so next, a white box testing techniques that measures the number of percentage decision executed by the test case design is called as, okay, a white box testing that measures the number of percentage of decision directions. So it is decision coverage, or you can say condition coverage also. Fine. So decision coverage or condition coverage. So this is also one of the good example that you should have. Okay, it could be a decision or a condition coverage. Fine. And I just want one example. Incorrect form of logic coverage is okay, just one second, we will just so this is something good. Okay, so this is the code, and you have to find the truth statement. Okay, we'll see this, and then let's see. This is the question number 230, so that we can just verify the answers. So this document I think I have already shared with you in the Telegram group. If you are not a part of this Telegram group, then please do join. Its description is given in a link is given in the description to join the Telegram group, so that you can have these notes at your side, at your place. You can see the previous sessions also. Fine. So let's find this. First we will draw the flow chart for it, and then we will try to find the correct answer. Okay, so A, B, then C, D and E. These are the options we have. Fine. So friends, are you getting the knowledge? Is your knowledge getting upgraded through these sessions? If you are liking this session, please hit the like button right now there, and also share this session with your friends and colleagues. These are free sessions. You can see the previous session playlist also in the description, so share that also with your friends and colleagues. Fine. So let's see this. Given the following, switch PC on, then start Outlook. If Outlook appears, then send an email and close the Outlook. So let's draw the flowchart for it. Okay, have I added this into our notes? Yes. So I can delete it. And what is being asked? The question is here, switch PC on. Okay, this is a normal statement, so I'll just have a statement here. Switch PC on. Switch PC on. switch PC on. This is the first statement, and the next statement is start Outlook. So start Outlook. Okay, next is what? If Outlook appears, then send an email. Okay, again condition is here. So check if Outlook appears, then what? Then send email. Send email. Else what? Close the output. Close the Outlook. Close Outlook. Okay, so let's complete the branches. So this is the flow chart. Okay, so let's see. So ultimately they are again asking how many statement coverage and how many branch coverage. So let's use our method to find the statement coverage and branch coverage. So here if you start from this path, this will cover these many nodes. So one path is there which covered these many nodes, but this node is untouched, so I will have to traverse again. So this will be my second path to cover all the nodes. So two statements coverage I have. So how many statement coverage? Two. Statement coverage is equal to 2. How many branch coverage? Again there are only two branches, so if you go through these paths, so this is one path and this is the another path, so branch coverage is also 2. So branch coverage is 2. So statement coverage 2, branch coverage 2. Okay, so the answer is 2 tests for statement coverage, 2 tests for our branch coverage. So this is my final answer. So let's check this question number 230. Question number 230. Here we are. So answer is B. Okay, answer is B. It says that one test for one test for statement coverage and 2 for branch coverage. It says that. Okay, so close the Outlook is not, I guess, the another uh, node. So close is something like a end statement. Okay, so it is like a end statement. So end statement would be here, because after sending your email also you can send you can actually close the Outlook. Okay, because here you see this is my mistake, I guess. So switch PC on, switch PC on, start Outlook, Outlook appears, yes, then send email, send an email and close Outlook. This is not the else part of it, this is just the part of this only. Okay, so let me just delete this. So this is not the else part of it, it is just a statement after the sending email. So after you send the email, you close the Outlook. Okay, just look at this. Okay, once again, switch PC on, start Outlook. If Outlook appears, then send an email and then close the Outlook. Okay, so there is no else part of it. Fine. So this was my mistake. So statement coverage is only 1. Okay, statement coverage is only 1 and branch coverage is 2. So I'll just delete this path. Okay, so branch coverage is 2, statement coverage is 1. Okay, so branch coverage is 2 and statement coverage is only 1. Fine. So the answer B is the correct answer. Okay. 1 for statement coverage, 2 for branch coverage. This is not the correct answer. Okay. So yes, I'll get this diagram into the notes. I'll share these notes with you. Okay, fine. And lastly, we'll see what is the cyclomatic complexity. So cyclomatic complexity is the source code complexity measure that is being used for correlated number of coding errors. Okay, it is calculated by the developer for control flow graph of the code that measures the number of linearly independent paths through the program module. Lower the program cyclomatic complexity, lower the risk of modify, and easier to understand. Fine. So how much complex your program is, so that you can verify with the help of this formula E minus n plus 2p. Okay, so if suppose E means edges, n means number of nodes, E means number of edges, n means number of nodes, and 2p, p means path, or you can just say 2. So look at this. This is a diagram wherein we have a flow chart of it. So here E minus n plus 2. Okay, E minus n plus 2. Okay, this p is not necessary. You can just write E minus n plus 2. So how many edges are there? How many edges you see here? This is one edge, and this is 2. Okay, let me find node first. So I'll take this diagram. Let's just take this into this. Okay, so here it is quite better. How many nodes are there? So let me calculate the nodes. Total number of nodes here are, say, 1 2 3 4 5 6 7. So there are total 7 nodes are there, right? And how many edges are there? Okay, so let's say this is one edge. Okay, this has one edge, this is second edge, this is the third edge, this is the fourth edge, this is the fifth edge, this is the sixth edge, this is the seventh edge, and this is the eighth edge. So total edges are 8. Okay, so what is cyclomatic complexity? Cyclomatic complexity is equal to E minus n plus 2. Okay, so edges, total number of edges are 8 minus node 7 plus 2. So 8 minus 7 1, so 1 plus 2 is 3. Cyclomatic complexity for this particular code is 3. Fine. So this is actually a developer tool, the cyclomatic complexity. Let me also add it into the notes. Fine. Great. So what we have learned in today's session? So we have learned that white box testing, will summarize this. White box testing is generally done by the developer at unit testing level. Okay, so when you have the knowledge of the code, you can do the white box testing. White box testing is something that when you find any bugs, you not only just check it from surface level, you go inside the code, you debug it, and you find out the errors where the things are gone wrong, right? Most of the times developer will do, but if you have a little bit knowledge of the coding, you can also do. At least you can suggest the developer that where the things could go wrong. If you, even if you don't understand the whole code, but still you can by practice or by experience, you can just check. I have one of the example I have given you. So sometimes what happens is that when you try to enter the details into one of the form and one of the detail is missing in the database. So for example, this fax number is not added to the database. So you can just suggest the developer that check this fax number, whether this fax number code is added to your program or not, right? So similar to this, if something if you have a little bit awareness of the coding, it will definitely help you. Fine. So I always say that even though we are a manual tester, even though you are learning a manual testing, but you should learn programming also, because there was a time when just the functionality testing was useful, but in these days you have to learn the automation also, right? So in case if you want to learn the Java programming, in this same YouTube channel, you'll find the different videos related to the programming. Like I have one playlist here. Okay, so let me just open my YouTube channel. I'll just, if you have not subscribed to this, please do subscribe. A uh, lot of important stuff, useful stuff I regularly add here. So I'll just show you one of the playlists in case if you want to learn the programming, so you can learn it from here. So let me just see Java programming somewhere. You can see here Java basics. So I'll just add this link also into the notes. Okay, so Java programming. Fine. So learn the programming, at least the basic of it. You will attempt to, you know, have some visualization of at least. Build your logical and analytical skills. More and more logical you are, more and more analytical you are, you will be able to visualize the logic behind your project, not just the functionality, but also sometimes if you get a chance, go and open the code and just see it. You may not understand everything, but just like I have shown you, if you get a chance, it is always good practice, so just open it and see. If you know any programming language, you can just guess what it could be. Okay, you may not understand everything, but at least start practicing this. This will help you, you know, to enhance your career. You will be getting more and more attention in your organization if you know the coding part a little bit. Okay, start with little bit. Slowly, if you develop the interest, uh, you will understand it more, and there are a lot of resources to learn the programming. Fine. So we are almost closing this session. So thank you very much for joining this session. If you have not subscribed to this channel, please do subscribe and also hit the like button. Please do like if you feel that this session has helped you, and also share it with your friends. One more thing, if you want to learn API testing, I am conducting one API testing workshop also on coming Tuesday. Okay, so I will share the link for that also. So you can just go to this link, amolujagare.com/upcoming workshop. Okay, so this is a link. Here you will find a workshop, 3 days workshop it is. So it's just worth 199. You can just enroll for it and you can attend and learn the API testings also, right? It doesn't matter what background you have, you can still learn. If you are a manual tester, if you are an automation tester, you will get a knowledge of APIs here, a lot of good knowledge of API testing here. Fine. So I'll give you this link also in the description, and you can keep checking the upcoming workshop on this link. Okay, amolujagare.com/upcoming workshop. This is my website, you can check. Okay, so amolujagare.com. Okay, so if you want to learn few manual testing stuff, then you can go to this website also. This is my personal blog, scriptinglogic.com. Here there is a section manual testing, so some text tutorials are there, software testing, so you can just go through it and you will get a lot of knowledge from it. Fine. So yes, how was today's session? Do you got knowledge? Fine. Okay, so I'm closing the session for today. That's all for today. We'll stop here and we will again meet on next Saturday. uh, Please share this session with your friends and colleague, and also ask them to see the previous session. The previous session playlist link is given in the description, and all these notes and the PPTs I'm going to share it on the Telegram group. Thank you very much for joining me, and we'll meet in the next week.